Welcome to my session, Using Progressions and Learning Trajectories to Guide Intervention in Multiplication and Division. My name is Shannon Olson, and I'm an educational consultant. I specialize in standards and progressions, and I'm excited to facilitate this session for you today. I'd like to get you set up for this session. So if you could head over to my website, shannonolson.com/virtual math summit, I'll share with you the options that we have. So once you get there, it'll ask you to add your first name, last name, and email. Go ahead and click submit, and then you can close that box, and you can see there are several different resources here for you. There's a note catcher that I'll tell you about in just a second. There are the PDF of slides, optional handouts, and also additional resources. If you click on the note catcher, it's a Google Doc. If you click make a copy, this will be your own copy. It's completely optional, but it's a great place where you can have a place to take notes and be able to view the different resources for the session as you go throughout the session. So I highly recommend using that. But again, it's totally up to you if that's something you want to use. You're also welcome just to sit and listen to the session. Now that we've got you set up for this session, let's go ahead and jump into our learning intentions and agenda for the day. So my goals today are for you to anticipate student thinking for multiplication and division, to observe and describe student thinking, to understand learning progressions and learning trajectories, and then to connect all of that to planning for intervention. I would love for you to think about what is your personal learning intention based on those goals and objectives. Go ahead and take a second to think about it, jot something down on your note catcher, and then we'll head into the agenda for the day. So we'll start with a math task. We'll look at some student thinking around that task, look at some resources for progressions and trajectories, look at resources for intervention strategies, and then we'll actually get to see some intervention in action, and then we'll wrap up the session from there. So here is our math task. We're going to start with a video where myself and a fourth grade teacher are planning for the task.
About where your class is at with multiplication and division in fourth grade?
Yes. So we've already taught multiplication. We taught that a few weeks ago, and these last 2.5 weeks we've been working on division. So we've done it in progressions. We started with 2-digit by 1-digit division, and then we've moved up to 3-digit by 1-digit, and then we focused on the area model because none of the students seems to be coming up with it on their own. And so that's where we're at. We're looking at moving towards doing 4-digit by 1-digit division, introducing that tomorrow, and hopefully helping them practice the area model more within that context.
Do you have an idea for a context that you want to use for your task tomorrow?
Probably candies is what we're gonna do. It's something simple, something that they're comfortable with. We're gonna add one of their names to the problem. It always gives them a little more buy-in to the problem if someone in their class is involved in the problem.
Okay, sounds great. So looking with a 4-digit divided by a 1-digit without a remainder, yes. Trying to aim for area model, but open to whatever strategies they're able to work with.
Yep.
Okay, a couple other things I am wondering is just how do you plan to group the students tomorrow? Like what will it look like when they're working together?
Yeah, so we're gonna group them in random groups of 3. So they're gonna get a little pencil that numbers them off by color and number, and that'll help them get into their random groups. And they're gonna have whiteboards around the room to work with and work in groups with.
This is a task. I'd love for you to go ahead and look at these 2 pictures and think, what do you notice and what do you wonder? Go ahead and add a couple of those things to the chat box. What do you notice? What do you wonder? Hopefully you're noticing that there's candy. It looks like a candy factory where candy is made, and then also a candy store where candy is sold. This is the task that was given to the students. Our class bought a candy factory. Our factory produced 4,824 bags of candy to sell. If we distribute the bags of candy equally to sell at 8 different stores, how many bags of candy will each store get? Let's go ahead and see Mrs. Snyder introduce this task to her 4th graders.
Will you tell your neighbor what is this? What is this a picture? Can someone raise their hand and tell me, do you know where candy comes from, like before it gets to the store? Sure. Hands raised, where does it come from? Let's see. Goldie, where does it come from? A factory. So this actually is a picture of a factory where they are making tons and tons of candy. And after they make it, they take it and it goes over into a store where we can buy it.
Where's
Yeah.
the Kit Kat factory?
All right, so our task today involves us. So we actually decided that we are going to buy a candy factory. So I know, give a little cheer. Woo, we bought a candy factory. Here's our task. I'm gonna read it to us. And then I want you to be thinking as I read, what are we trying to solve for? Okay, so Mrs. Snyder's class bought a candy factory. Our factory produced 4,824 bags of candy to sell. If we distribute the bags of candy evenly to sell at 8 different stores, how many bags of candy will each store get?
Hey, let's go ahead and take a second for you to solve the problem using any strategy you want. Also thinking about how fourth graders might solve the problem. Give you a moment to solve. Okay, now that you've solved the problem on your own, I'd love for you to really anticipate student thinking. How might students solve the problem? What strategies and representations would they use? What errors or misconceptions might they have? Go ahead and take a moment to record how you think students might approach this problem. Feel free to add some of your strategies to the chat box. This is also a great place to record your thinking on the note catcher if you chose to make a copy of that. Okay, let's go ahead and examine some student thinking of what students actually did with this task. This is group 1, so this is a picture of their work. You can see they've got some circles with numbers. They've got an attempt at an area model. Let's go ahead and watch a video of them working through this task.
Are you guys gonna keep track of how many bags of candy you've given to the stores already? Like, are you gonna keep track of how much you've given to the store and how much you still have to give to the stores to sell?
These all up, and then we'll have 800 somewhere. We'll have 800.
Is there 800 in each or 800 total so far?
Yeah, 800 total. 800 total.
100 each. Okay.
I feel like we could add more. Add another. Could we add another 50? Let's add another 100. In each? Would that be
Okay.
6? Yeah, that's too much. That's 16. If we put, no, these are 200. If you put 200, so 200, 400, 600, 700. Well, we're just putting another 8. Like 1,000. Total be we could 1,200. 14, 16. That's 1,600. I feel like the area model would be easier. It's 500 because 5. Oh yeah, 500. So 300 in each. Yeah, 300 in each. I think we should have made bigger. But it's okay.
You guys, Christian's gonna come on your guys'
Now we have 500 in each. 510. 1,000. 1,500. So we're at 40. We only need 824. So we can do 100 because 100 times 8 is 800. You could write some.
I think we should just write 500 in each.
Yeah, let's just write. Should we honestly just write 600 in each?
No.
Should we just base it right 500?
500 and 100.
500 and 100. Yeah. Wait, what's the ratio?
Where do you see the 8 stores in this model?
These. Yeah.
Where do you see the 8 stores in this model?
This.
Yeah, like our 8 rows, right?
Yeah.
Okay. And then where do you see the total number of candies in both of them? Okay, so you can add different things.
Wait, the total candies?
Yeah, where's our total number
Oh,
of
at
candies?
the very end.
What do you mean the area, Finn?
Oh, at the very end, it's 603.
So 603, you're saying that's our answer?
Yeah, that's our answer, but she's saying, listen at her saying, what's the total of our candies? Division answers are usually way littler. Why is this one bigger?
So why is, so Jacob, you're asking why is 603 so big?
Yeah.
Why isn't it like 6?
Yeah.
What do you think, Finn and Troy?
Because the number is like 4,824. It's because it's bigger numbers.
Yeah, there's a bigger number of candies to start.
Looks like group 1 has a pretty good understanding of a fair sharing equal groups model. They understand that the candy is being distributed equally to the groups. Looks like they also feel fairly confident in attempting an area model, but they spent most of their time on the equal groups model. They seem to have an accurate answer. A couple of things I'm wondering is, do they understand like the large quantities? Like, can they grapple with what is a 4-digit number and how can I make sense of like actually how many candies would be in each of those groups? It's something that like they could look for some more efficient strategies and thinking about how the divisor fits into the dividend. All right, let's go ahead and look at group 2. So this is their work. You can see they attempted an area model first and then went back and tried an equal groups model. Let's go ahead and look at their thinking. And again, we're looking for what is the evidence of their thinking? What do we notice they understand? What are we wondering about what they understand?
You want to try 1,000?
No, that only equals 2,000.
What do you think, Bronson?
Only equals 2,000 times.
I kind of want to do 8. I kind of want to do like maybe just like 500 because we have 800 and I think 1,000 would still be a little bit too much bigger, too big.
Now, what do you mean it might be too big, Harper?
Because it's just one less and so because 816 so 800 would be 8,000 we don't have 8,000 so
Yeah, I agree. Yeah, I agree with Harper. Let's do 500. Do you agree with
times
8 equals, take the 2 zeros away. 8, 16, 24, 32, and 4. Oh, looks like you have to add 4,000. So that would equal 4,000. Okay, and then we would minus that
Okay, so can you tell me why you're taking away the 4,000?
because we've used 4,000 already.
Yeah, 4,000 of your what?
Our
candy.
Yeah, you're giving out 4,000 bags of candy to your 8 stores. Yeah.
Okay, because we already got 4,000, so what do you think we should do, Harper?
Maybe we should do minus 200 up here because we have 800.
Can I have an eraser, please?
I have no idea where it is. So then it'd be equals 800. Equal 800.
Holy Harper.
Now let's say
24. Then what do you think the next number should be, Bronson?
I need to 20.
20. Okay.
Okay. And then
So then you just, so 20 times 8. 8, 16 equals 1,600. So we can't do that because that's way too high.
Yeah, but we can't do anything else.
What about,
Without taking that 4 away.
what about 5?
Nope, 5 will work.
Yeah, let's just try it.
5, definitely not.
16, 24, 32.
Okay. How about we do 3? Let's try 3.
That equals 24.
Huh?
That equals 240.
Oh. What should, let's do 2?
Yeah, how about we just do 2 and just
8, 16. So that's 16, so that's 16.
8. And then 1 minus 1, 0. We got to 8.
Okay, now do that. Now I think we should do 2 again. And we minus that, and we got 24, and then we bring the 24 up here, and we did 4 minus 6, you can't do that, so we got the 2, and
Now the 2 becomes a 1, and the 4 becomes a 14. And 14 minus 6 is 8, and so put the 8 right here, and then 1 minus 1 is 0, and then we just added 1, and we did 8 times 1, and 8 times 1 is 8, and so we did 8 minus 8, which got us 0, so that means we're done with that model, and then our answer is?
Our answer is 603 because we added the all of these, like we added the 500, the 100, the 2, and the 1.
I'm thinking about group 2. Go ahead and add to the chat box a few things you notice and wonder about their thinking. A few things I noticed evidence of them understanding is they do understand the area model. They do understand computation and the relationship between multiplication and division. It looks like they were able to reason about 500 groups of 8 or 8 groups of 500 would fit into the 4,824, but 1,000 groups would not. They knew that 1,000 groups of 8 or 8 groups of 1,000 would be too much. So they were able to reason about that. Something I'm wondering about their understanding is their understanding of basic facts. It was 24 divided by 8, and they were sitting there grappling. Could it be 20? Could it be 5? Could it be 3? No, it can't be 3. It's 2. And then they ended up like pulling out 2 groups of 8 and then an additional 1 group of 8. So I wonder how they could better utilize their basic facts and their reasoning about number sense. Well, I do think they have a pretty solid understanding of the area model for multi-digit division. Let's go ahead and look at group 3. So you can see that group 3 tried several different strategies and models. They had an equal groups model. They also had an area model. They also attempted partial quotients. And they also were looking at pulling out groups of hundreds, first 200, then 400, and then 3. So let's go ahead and look at their video, and then we'll come back and unpack their thinking a little bit more.
We started with 200 and we divided, times 200 by 8, and we got 1,600, and we minus that from 4,824, and we got 3,224, and then we did 400, which gave us 33,200, and so we minus that and got 24, and then we did 3, which gave us 24, and so we minus that, minus 24, and that gave us 0, so we knew we had no remainders, and then we did 200 plus 400 plus 3, which gave us 603.
Great. Go ahead and add to the chat box anything that you notice evidence of their understanding, things you wonder about their understanding. I'm noticing that they are able to apply different strategies. It looks like they can work with equal groups, the area model, and partial quotients all accurately, fairly efficiently. Seems like they are making sense of the strategy. Their computation is accurate. A couple things I am wondering is, are they looking at the digits and the quantity in the dividend as they go to divide the divisor? Because I think they could come up with even some more efficient strategies. But I think for where they're at in 4th grade, this is it's a new concept. As you know, this was the first day they were exposed to working with 4 digits. So I feel like it's fairly efficient for where they're at right now. But I would also like to wonder, like, where did they come up with the 200 and the 400 and the 3 as they worked with those partial quotients to get the 603? Okay, we're going to take a pause from looking at the work in the student classroom to examine learning progressions and learning trajectories, and then we'll come back to the student thinking to apply these progressions and trajectories. So there are a lot of different ways we can think about progressions and trajectories. One of my favorite ways is to think about them as a pathway that students are learning on. So that learning progressions and learning trajectories inform the pathways in which students learn content. Sometimes these terms are used interchangeably, but depending on the source and context, there are a few differences. So I'm going to share with you several different resources and sources and how they define progressions and trajectories. Like I said, sometimes they're used in the same way, sometimes they're used in different ways. I'll share with you how I have chosen to define and work with the terms progressions and trajectories in my work. So one way to think about them is as a continuum. So Karen Hess in 2014 said that learning progressions, progress maps, developmental continuums, and learning trajectories are all terms that have been used in the literature over the past decade. Notice that was a decade ago, and that we're continuing to see all of these terms used now, even a decade after this. And she's saying that many variations of definitions exist, but basically, we're referring to research based descriptive continuums of how students develop and demonstrate their understanding over time. Another way I like to think about progressions and trajectories is as building blocks. So, in a more recent article, it is defined that learning progressions describe typical sequences of learning in specific areas, so specifically math or specifically multiplication and division, and that those learning progressions focus on the building blocks that contribute to mastering a particular skill. And it's really a map to help us think about the stages that students progress in their skills and understanding over time. Another way to think about progressions is relating it to the standards. So the standards in mathematics were built on a progression of topics across a number of grade levels, informed by both research on children's cognitive development and by the logical structure of mathematics. Today, I will be referencing the Common Core state standards for mathematics because most states use them or use a variation of them. If you're in a state that doesn't, this is still completely relevant to you, and I'd be happy to discuss with you what the progressions look like in your state. This is a resource that really helps describe what progressions are. We're not going to read it today in the session. I just wanted to share it with you so that you could save it for later. But basically, when the Common Core state standards for math were written, there are these lengthy progressions documents that describe for every given topic or strand or domain in the core how concepts connect over time across the grade levels. So these are originally published in draft form. You'll see some that were 2011, 2013, 2014, and the drafts were revised over time by different domains in the core, like numbers and operations in base 10, operations and algebraic thinking. And then in 2023, just last year, the final draft came out, and it's all in one document, but there are bookmarks that you can go and find the different topics if you're looking for something more specific rather than reading several hundred pages about the progressions in the math standards. Highly recommend it. There are a couple places when we're talking about multiplication and division that we would want to look at, both the operations and algebraic thinking domain, because that's where we understand what does it mean to multiply and divide? How do we conceptualize those operations? And then as we move into numbers and operations in base 10, we compute using place value to multiply and divide. So as we're looking at progressions and multiplication and division, we need to attend to both of these. I have linked them in the handouts for you, the pages that specifically refer to multiplication and division. So I highly recommend checking those out when you have some time to study progressions a little deeper. Another resource that I highly recommend looking at for progressions is the coherence map. This comes from Student Achievement Partners, also known as achievethecore.org. And if you click on this link, you can click on any standard and find a map that's interactive of standards that came before, standards that come after, how they're connected. There are sample tasks. Really, really great resource. I highly recommend checking that out when you're working with progressions. You can see in this 4th grade division standard, we're connecting to previous standards in 3rd grade related to both base 10 and operations and algebraic thinking. And then we're also looking at standards in our current grade as well as future grades in both of those domains as well. Hey, I have pulled out standards that I believe are aligned to multiplication and division. And like I said, I'm happy to help you make some correlations with your state if you don't follow these standards. But I'd love for you just to pay attention to the number of standards per grade level. In some cases, it is specifically standards that list the words multiplication and division. In K1, 2, they're more prerequisite skills. They're things that I have either through the coherence map or on my own connected to the concept of multiplication and division. So you'll see in kindergarten, we've got a couple of standards connected to just counting and understanding quantities that directly feed into the concepts of multiplication and division. First grade, understanding the meaning of the equal sign. Second grade, we've got a couple of foundational standards as we work with equal groups, but notice the number of standards in third and fourth grade. That is really where multiplication and division with whole numbers is taught. Third grade, 8 standards. We've got standards that help students identify what does it mean to multiply and divide. We've got standards that identify working with word problems, working with properties, and then beginning to work with place value with multiplication and division. In fourth grade, we're introduced to comparison problems for multiplication and division, as well as working with place value, multi-digit multiplication, multi-digit division. Fifth grade, notice there are 2 standards, one for multiplication with multi-digit numbers, one for division with multi-digit numbers. And by the time we get to 6th grade, there's one standard that says students should be fluent with multi-digit division. So just notice as you look at those standards later on at your own time, that you're able to recognize and notice how those standards relate to the progression and where the focus is in the grade levels as we teach multiplication and division over time. Okay, this is another document that I have created for you. It is also linked in your materials. But basically, it's taking all of that lengthy language in the standards and unpacking what is the progression of multiplication and division. So when we look at context and problem types in third grade, students are introduced to equal groups, array and area problems, and measurement quantities. With all of those contexts, we're working with unknowns in all places. So products unknown, group size unknown, and number of groups unknown as we work with multiplication and division. As we move into fourth grade, we're still working with unknowns in all places, but we're now working with comparison problems and also interpreting whole number remainders. Fifth grade, no problem types are explicitly listed, but we're just continuing to work with all of the problem types that could have come up in previous grade levels. When it comes to place value, third grade, the emphasis is within 100. So multiplying 1 digit by 1 digit numbers. It can also include multiplying other problems within 100. For example, 2 times 48 or 3 times 25. Some states have removed that part from their core, but in most states, it is still actually part of their standards. So I'd recommend looking at your specific state standards to see if other problems within 100 are part of your standards. And then dividing 1 and 2 digits by 1 digits without remainders. So that would look like 36 divided by 6, 24 divided by 3, those types of problems. Students also begin to multiply 1-digit whole numbers by multiples of 10. So 5 times 60, 9 times 80. As we move into fourth grade, the real focus of fourth grade is multi-digit whole numbers. So you can see that they are expected to now do a 2-digit by 1 digit, 3-digit by 1 digit, 4 by 1, and 2 by 2. Sometimes I have seen curriculum jump really straight into those 3 and 4-digit by 1 digit numbers. I highly recommend starting with the 2-digit by 1 digits first, especially as you look at where students are coming from in third grade. When it comes to division, we also have 2-digit, 3-digit, and 4 digits, all divided by 1 digit. And then as we move into fifth grade, that's when the standard algorithm is introduced or expected for multiplication. So notice it's not listed in fourth grade for multiplication or division. And then the difference when we get to fifth grade for dividing whole numbers is we now have a 2-digit divisor rather than just a 1-digit divisor. Okay. Looking at fluency, in third grade, students are expected to fluently multiply and divide within 100 using a variety of different strategies, and then to also know from memory or quickly use mental strategies to know their products of 2 1-digit numbers. So looking at everything from 1 to 9 and knowing those facts. They're learning what multiplication and division are, as well as becoming with those facts. Fluent with those facts, all in third grade. Fourth grade, there are no fluency expectations in multiplication and division. So it's recommended to continue to work on the fluency expectations from third grade. Fifth grade, multi-digit whole numbers, multiplying with the standard algorithm. A couple other things to notice in additional concepts and skills. In third grade, we've got the properties introduced. These properties, commutative and associative, were introduced in first grade for addition and subtraction, but they're now being applied with multiplication. And then the distributive property is also introduced as a way to help students problem solve and reason through multiplication problems. Notice there are also two-step word problems using all four operations. In fourth grade, we focus on not just knowing our multiplication facts, but analyzing factors, multiples, prime numbers, composite numbers, and then solving multi-step rather than just two-step word problems with those four operations. In fifth grade, multiplication and division are applied in writing and interpreting numerical expressions using those four operations. And then students also make sense of place value as they multiply and divide with powers of 10 to understand the place value system. So there's kind of a snapshot of what progressions look like in multiplication and division in grades 3 through 5. Where we're focusing today in the lesson we're going to see in Mrs. Snyder's class is in this fourth grade division of whole numbers. We will see some concepts and skills from third grade come into play, but notice that in this situation, we're actually working still in fourth grade within a progression and trajectory of student learning. Okay, another way to think about progressions and trajectories is to think about how students learn. So when they learn and how they learn different concepts and skills. So this is referring to learning trajectories, and it's saying that they offer a little insight into how to teach topics, that they're empirically grounded descriptions of how students' reasoning evolves from less to more sophisticated. It's thinking about how we can teach topics and how topics develop and evolve across the grades. Another analogy that I really love when it comes to talking about learning trajectories is climbing a rock wall rather than climbing a ladder. A climbing wall assumes that climbers move upward from a variety of starting points through multiple paths, and they make student thinking visible and predictable. And I love this because a lot of times we talk about ladders when we're talking about trajectories and progressions that we expect students to master. But really, students should all be working upward, but they might take different pathways depending on where they're at and the skills that they're building. Okay, another way is just to think about natural or developmental growth. So children follow natural developmental progressions in their learning, and research has revealed that there are sequences of activities that are effective in guiding children through these levels of thinking. And so we'll look at some learning trajectory resources that are based on those sequences of activities grounded in research. So this is another tool I would love to share with you. It comes from Doug Clements and Julie Sarama. If you click on the link, you can head to their website. They have identified learning trajectories for several different concepts for early learners. They look at birth to grade 3. And if you click on multiplying and dividing, for each of those different levels in a learning trajectory, you can see examples of what a student might work and look like and be working through those concepts at those levels, as well as resources to support them advancing through those different trajectories. Okay, this is another resource that I have put together. So you can see that I have referenced those learning trajectories from the Learning Trajectories website. And then I have also referenced a few additional resources and books, as well as standards, to identify other trajectories, such as numerical patterns and strategies and representations. These are a progression or trajectory in which students might work through. This is how to teach these concepts that come up in those standards that tell us when to teach the different concepts. So notice that when we're working with one-digit numbers, the research does not recommend starting with ones, twos, threes, fours, fives in that specific order, but starting with what is called foundational facts first. So twos, fives, and tens first, things they're used to doubling, skip counting, and then working with zeros and ones, and then nines as they derive those from tens, and then threes, fours, sixes, sevens, and eights. And then notice the place value progression as we multiply within 100, then multiples of 10, and then those multi-digit whole numbers, with the standard algorithm being the very last thing that students are expected to learn, and that they're expected to learn it for division after multiplication. Strategies and representations, you'll see a lot of physical objects along with visual drawings, beginning with equal groups, then arrays, area models, and number lines. Lots of other different strategies will move into repeated addition, repeated subtraction, and then also looking at partial products and partial quotients before moving into algorithms as well. So again, this is linked in your handouts. Highly recommend using it as a reference as you support student learning of where to go next as we're building student thinking. Just a couple of ways to summarize how I'm defining progressions and trajectories. So I view learning progressions as describing how big ideas advance through the grade levels and the way standards connect over time. They tell us when students learn concepts. I'm defining learning trajectories as the pathways children naturally take to develop mathematical understanding, and they're telling us how students learn concepts. A couple examples. The coherence map gives us an idea of what comes in third grade, fourth grade, fifth grade, whereas trajectories will tell us students are going to become skip counters before they're most likely to derive facts. Okay, a couple ideas just to think about an example of what a progression might look like and a trajectory might look like using these specific resources that are available for free for you on the internet. Okay, thinking about application, how do we apply them? When we're thinking about progressions of when concepts come up in different standards, that is great to plan for whole class instruction. How can we activate background knowledge of where students are coming from in previous grade levels? How can we really focus in on the content of our grade as we prepare them for the future grade without going into that grade? Making sure we're really targeting grade level instruction and knowing and attending to the flow of big ideas across time. When it comes to trajectories, these can support us in planning for differentiated instruction. As you can see in the videos that we already watched, some students were really drawn to the equal groups when other students were really ready for the area model or even partial quotients. It can help us plan for skill-based instruction. So really helping students identify the skills that they need to master before they're ready to work in other concepts and skills, or at least those ones that will support them as they move into other concepts and skills. It also helps us to know the flow of developing those individual skills. So along with looking at progressions and trajectories, we're also going to look at a few intervention strategies. So this is a list that I have put together, and a reference I'm using is the What Works Clearinghouse practice guide for assisting students struggling with mathematics. So that is linked in the resources and references. I recommend checking it out. But some of the ones I've pulled out are aligned here. So we'll go ahead and take a look at each of those. So again, progressions. We should use them to know when to teach concepts in relation to other concepts as well as grade level expectations. Trajectories, we can use them to know how children develop understanding of concepts. Knowing our progressions and trajectories are great to support intervention. Other things are systematically aligning our intervention to core instruction, ensuring that what we're doing in intervention directly supports learning in Tier 1. So often I work in schools and I see our students who need the most support. Perhaps they might be working on fractions in Tier 1 and getting something on multiplication division in Tier 2, and then getting something related to like adding and subtracting with place value in their Tier 3 instruction because that's what like an assessment said that they needed. So I am not advocating that we don't use diagnostic assessments or things like that. But what I am asking is that we just look at our students who are receiving intervention, whether it be Tier 1 or Tier 2, and see as much as possible how can we align that intervention to support what's happening in Tier 1 so that we don't have our students who need the most support learning the most different concepts at the same time. So if we're working on multiplication and division in whole class, our intervention should be things that are aligned to multiplication and division or helping students access multiplication and division in intervention as they go to apply that in Tier 1. Context is super important. A lot of times we may have grown up learning math where we learned to compute first and then we did word problems at the end. The research now supports leading with context and using context in intervention. As we propose situations and word problems to students, they can understand and deepen their understanding and support their capacity to apply the mathematical ideas. If you look at the video from today, a lot of the students really were talking about the candy and the groups and how many of the store, how many candies would the different stores get, rather than just worrying about the computation. Mathematical language. It's really important to allow students to naturally use informal language as they develop understanding of concepts. And then once those concepts are surfaced, we teach clear and concise academic language. So that means not pre-teaching vocabulary. There may be a time and a place to work on vocabulary with students. I'm not advocating that we don't work with vocabulary, but that we explicitly teach vocabulary once students actually have some context and application to make sense of what those words mean as we teach them to them. So letting them use that informal language as put them in groups or share them before we talk about, oh, we're dividing. And then eventually we do want them to use that clear, concise academic language, but as they're making sense of it connected to the math they're doing, not teaching vocabulary in isolation. Another strategy that's really important is representations. So providing students with physical tools to solve math problems and then helping connect those physical models to pictorial and other representations, and also regularly including number lines as representations as students are working through the different mathematical concepts. Okay, let's go ahead and watch some intervention in action. So we're going to first get to see some planning that took place after this lesson. We are going to watch planning for intervention that take place the same day as the Tier 1 lesson, but know that the teacher had already been teaching Tier 1 instruction on multiplication and division. We're not intervening necessarily after one lesson, but after several lessons. So we want to make sure that students do have multiple opportunities to respond and interact with the mathematics before we jump into intervention. So know that this is like mid-unit after students have already had a lot of exposure to multiplication and division. Based on looking at the student work, what are you thinking might be a good plan for some small group intervention?
Yes. So I'm thinking, looking at the 3 groups, this one right here probably can be addressed in whole class. As long as we focus on, as a whole class, finding bigger chunks and trying to find the most efficient strategy, I think these students will get there without me pulling them back into a small group because they're understanding division, and I think they'll start seeing, oh, this is faster and more efficient and I want to try this. So this group we're gonna just leave to whole class. So this group could also probably be addressed as whole class. This is the one where they are not quite as fluent with their basic multiplication facts from 3rd grade. However, I think that pulling them back just for maybe 5 to 10 minutes and addressing it with them, maybe even faster, would be something that's helpful. This group is the one that needs the most intervention, and they are the ones that we see a lot of different holes, and they all look different. We have some that don't know where to start, some that you're getting numbers in a lot of different places. I'm not sure where the numbers are coming from for some of them. Same with this one. And then again, just not 100% sure maybe how to finish the problem or where they're going all the way. So going back and thinking through progressions of student thinking with these students, I want to go backwards and start with 2-digit by 1-digit division. And I will probably do that using, in fact, I will do that using context and representations just to see what they do and see how they understand that. Because if they don't understand that, then we need to stop and make sure that they're clear on that before we move forward to the next step.
We're going to get to watch some intervention. These are the things I'd love for you to look for. So evidence of student thinking. What are the students thinking? What do they understand? Evidence of learning progressions and learning trajectories. So where do we see Mrs. Snyder attending to progressions and trajectories? And then what is some evidence of intervention strategies that we also see?
Can you tell me what 16 divided by 4 is? I'm gonna pause you guys right here. Okay. Okay, I love seeing you guys do some area model I love seeing your representations of the area model. I want you to think to yourself for a second, did you need an area model to solve this one? No. Do you remember solving this last year in 3rd grade? Does this look familiar? No? Do you guys remember skip counting to solve division?
Can I do it kind of backwards?
I skip them backwards, kind of like you go 12, 16. How many groups of 4 does it take to make 16? 4. Yeah. Was that easier than doing the area model for it? Yeah. So I want us to look here at our work from yesterday. See, I love all the stuff you did, and it was awesome. The groups you pulled out were great, and you subtracted really well, and you represented things really well. Looking here at the end though, can you guys tell me? We did, it looks like for both of you, 4 groups of 3 to take out 12, and then we did 4 groups of 1. Did we need to do 4 groups of 3 and then 4 groups of 1?
No, because one was that.
So we did still need to take out. I guess my thought is, could we have just done 4 groups of 4? Yeah, would that have been one less step for us to do? Yeah, because you guys just showed me that you know what 16 divided by 4 is, right? If we have 16 left and we have 4 groups, we just need to try and remember those multiplication facts from 3rd grade, the ones, and the division facts from 3rd grade to help us solve that answer. Does that make sense? Does that sound good? Okay, so the reason I pulled it back was just super quick is when you get to the end of your area models, if you get to numbers that you recognize as numbers that you used in multiplication facts in 3rd grade, I want you to try and refer back to those before you do groups of 3 and groups of 1.
Hopefully we were able to see some evidence of student thinking that they do understand what division means. They do understand some of their basic facts, and the evidence of the teacher using progressions and trajectories is going from 4th grade back to 3rd grade of the standard of understanding basic facts, becoming fluent within 100, but also working with the 2-digit divided by a 1-digit. And then when it comes to strategies for intervention, in this case, the teacher specifically didn't choose to use context or representations because it's a procedural intervention rather than like a conceptual intervention. So she's really just thinking about aligning to tier 1 and supporting the students in that way. Let's go ahead and look at another example. So we're looking at intervention with context and 2-digit dividends. So this is the problem that was presented. 4 to 8 people going to the zoo. 4 people can fit in a car. How many cars do we need? And let's watch that video.
Today, I'm making sure we understand and are really clear on what division is. That's our goal today. And to do that, we're going to practice solving some different problems. If you want to use these manipulatives here, you're able to. You can just take them and use them to solve, but you don't have to. Okay? What are the numbers that are most important?
48.
48, because that's how many people we have coming.
4.
And 4, why 4, Goldie?
Because
That's okay. So there's 48, and we're putting them into...
4. Only 4 people.
Yeah, only 4 people can fit in a car, right? And we need to figure out how many cars we need. So let's start with, I want you guys to try this. You can talk together if you need. What do you think we're solving for here? Or I guess, what equation should we use to solve for this? What do you think?
98 divided by, there's 2 cars, right?
There's 4 people that can fit in a car. Yep.
So 48 divided, there's 2, you said there's 2 cars, right?
So we don't know how many cars. So that's what we're trying to find. Yeah. 48 divided by 4, because there's going to be 4 people in each car. Yeah, so we know our total number of people, and we're splitting them into groups. That's my cue in my head to know that that is division, because I have a total number of people, and I'm putting it into groups. I'm putting them into cars in this situation. All right, so I want you to try this. How would you solve this? What you did for us.
So I put 4 circles and then I counted up in each circle. So I went like 1, 2, 3, 4 until I got to 48.
Uh-huh.
And then I counted what I had in a circle and it was 12. And then I just checked the answer.
Okay, how did you check your answer?
I did. So I knew that I had 12 in here, so I just put 4 12s, and then that equaled 48. So
Okay, so you knew that if you had 48 little dots in your circles that you had done your math correct? Okay. All right, let's see. Really quick on this. Where do we see, and Anthony and Oakland, I want you to help me on this. Where do we see the, let's say, the 4 people in each van?
Like in circles.
yeah,
So normally it's like in the circles, but how many people go in the van?
4.
4. So really, it's interesting, right? So really, where do we see the 4 in this picture?
In the cars. And like
It's the big circles, right? But really, we're trying to represent 4 people in each car. So we got the answer right, but is this maybe the best representation of what's happening in the story? You're right, and why not?
because there's not 4 people in each car.
Yeah, there's not 4 people in each car. If I was gonna do 4 people in each car, I would pull out, let's say, 48 tiles. You guys wanna help me make sure we have 48 here? Let's just check. So let's pull out some here.
Can I still
Maybe yes. But let's start here. So maybe let's count up by 4s until we get to 48. Does that work? Okay, so here's 4 people in one car. We're at 4. There's 4 people in the second car. That's 8. 12.
16,
16.
20,
What comes next, Oakland and Anthony? 20. And then what comes next? 24. We can even just count on by 4s, right? And then here's another 4. 28. There's another 4 in the car. 28. What comes next? Let's do 28.
32?
Yep. 29, 30, 31, 32.
40,
Let's double check. 32, 33, 34, 35, 36. We've added 4 more. And then we're gonna add another 4. What comes after 36, Oakland and Anthony? What do you think? We added 4 more. 40. Okay, there's 44 and 48. So now do we see the 4 people in each car? Thanks, Goldie. Missed it right there, huh? All right, let's count how many cars there are. Can you count? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what's our answer? How many cars do we need?
I was just thinking
12
that they were thinking like
I was thinking
I
like
forgot that you had more cars, and I thought that like 10 would not fit unless you have to squeeze in a lot. So
Yeah.
it worked.
Yeah, so is what you're thinking here, Anthony, you're looking and saying, well, in my cars, if my circles represent my cars, it'd be hard to squish 10 people into a car.
Yeah.
Yeah.
Unless you put them in the trunk, but
Yeah,
that
but
would
that-
not be comfy.
That would not be comfy or very safe either, huh? Yeah. All right. But Anthony, do you want to explain your strategy really quick?
Yeah. Okay, so what I did is that I did like 10, 20, 30, 40, that's like 40 right there. And then I did 2 circles, and then 2, 4, 6, 8, and then that would equal 48. But I just remembered in with 12 people to fit, so no.
Yeah. And that's okay. Did we get the right answer using this model?
Yeah, we did.
Yeah.
We could do more cards.
Yes. So this strategy will get us the right answer, but it doesn't match the model of our story,
Yeah.
right?
Hey, I'd love for you to think about what did you see in those videos for intervention, evidence of student thinking, evidence of learning progressions, and evidence of intervention. I saw the students making sense of what it means to divide. I feel like they were actually understanding we have a total amount of items and we need to share them equally. There was evidence of the teacher using learning progressions and learning trajectories as she went to a place where it's not single digit facts, but it's an easily accessible 2-digit divided by a 1-digit. And then also looking at the trajectory of working with physical objects as we move into visual drawings. And then the intervention strategies are working with progressions and trajectories, context, and representations. She was really focusing on the context of the problem as well as having students use those different representations and then explain their representations. Okay, we're going to go ahead and close and reflect on this session. So I'd first love to say a thank you to Mrs. Snyder and her class. We appreciate her allowing us to come in and film. And then also, I'd love for you to take a moment and think about what do you want to remember from this session? Go ahead and jot this down on your note-taking guide. Feel free to add something into the chat box. What do you hope to remember from this session? Okay. I'd also love to invite you to connect with me. Here's a link to the ways you can contact me or follow me on social media. I'd love to connect with you and hear from you. I'd also invite you to book an initial consultation if you're interested in working with me or just seeing what I offer. You're welcome to click on this link or grab the QR code. I also have some online courses that you can check out if you're interested in looking at some further learning that has university credit. And just want to say thank you so much for your time today. There are also resources and references linked here for you to access after the session. Thank you again. Hope to connect with you. Feel free to email me if you have any questions and have a great day.